a video tutorial on factorising expressions. So just a few examples on factorising. So hopefully you're a little bit familiar with some of this stuff. It does get a little bit harder towards the end. So we're going to start off with this one here. So the first one. So there's a few ways you can factorise. The first way you should be looking for is to find a highest common factor. So in this first expression here, we're looking at, we've got two terms, negative 4x and negative 20. So we're looking at the biggest number, so the highest common factor, or HCF, of negative 4x and negative 20. Now both of those divide by 4, and in fact they both divide by negative 4. If you have a negative factor, you should probably take it out. Okay, so let's say negative 4. So what you do, at the front of a set of brackets, put in your negative 4, then you divide both terms by negative 4. Okay, so negative 4x divided by negative 4 is just x. Negative 20 divided by negative 4 is positive 5. Okay, so that's that first expression factorised. Now, second one here, if you look at the coefficients of these terms, 25 and 15, you could probably work out that there's a highest common factor of 5. But we're also looking at the pronumerals as well. So what's the biggest number? Both of these numbers, a squared and a, divide by a. So the highest common factor of these two terms is going to be 5a. So in brackets, we divide the original term by 5a. So 25 divided by 5, 25a squared divided by 5a is going to be 5a. Okay? Plus 15a divided by 5a is going to be 3. Okay? So that's that one done. That is fully factorised. The third one here is a little bit trickier, but there's two terms, 2 times x plus 3 and negative y times x plus 3. Now, it's not immediately obvious what the common factor is, but both of these terms have multiples of x plus 3. So in this case, the HCF, highest common factor, is x plus 3. Okay, so what we do is we take out x plus 3, okay, at the front, and in brackets, whatever's left over. Now, 2 brackets x plus 3, divide that by x plus 3, you're left with just 2. And negative y times x plus 3 divided by x plus 3 is just negative y. Okay, now that's the answer. It's fully factorised. Okay, so there's these ways. This is the highest common factor way. I'm going to move on to these slightly trickier ones where we use our special products rules, DOPS or dots, depending on who you've learned it from. They're both the same thing, difference of perfect squares. Okay, so you'll notice in these, well, the first two at least, there's no highest common factor, x squared and negative 9. This first one here, they don't share a common factor. There's no, you can't take out one thing from both of them. What we can do though is we could recognise a difference of perfect squares. Okay, both of these numbers are perfect squares. So x squared is obviously perfect, is a square number because it's something squared, and 9 is 3 squared. Okay, so in the previous chapter we were looking at expanding difference of perfect squares. So this is going back the other way. So you have to be really good at recognising them and then applying them. Okay, so when we have the difference of two square numbers, we could say that we factorise it to the first number plus the second number times the first number, take away the second number. Okay, so x plus 3, x minus 3. Okay, so that's the yeah. And in fact, if you use FOIL to expand this, you will get that original question. So this works just as well. So sometimes it's not quite as obvious when you're dealing with square numbers, but you're going to have to learn to recognise these. 9 is a square number, 4 is a square number. A squared is squared and B squared is squared too. Okay, so the best thing to do is to put these into square number form. So that's going to be 3a squared. Remember that this 3, when you put to the power of 2 out the brackets, that's 9 gets square rooted as well. minus 2b squared. Okay, so you've got two square numbers. And again, applying our DOPS rule, it's the first number minus the second number times the first number plus the second number. That's a b. Sorry, I might just fix that up. There we go. Okay, so some of these, they're not always square numbers. Okay, this third one here, 12x squared minus 1200. Now that is, well, even though there's an x squared there, the 12 and the 1200 are not. Okay, so in this case, you have to do something else first, which is we factorize it. Factorize by taking HCF first. Okay, so we can take out a highest common factor from both of those numbers, and what you'll find is most of the easy ones, or the ones in the textbook, are set up to come out as square numbers. So if you have a look at 12x squared and negative 1200, they both divide by 12. So if you take that out, 12x squared divided by 12 is x squared, and negative 1200 or negative 1200 divided by 12 is negative 100. Okay, and they're kind of designed for practice, but you may notice that these are now square numbers. Okay, so you can write it as a square number, 12, whoops. So that's still 12x squared minus 10 squared. We can write 100 as 10 squared. Now we've got the two squared numbers, so that you can't forget the 12, that still stays there. But this one will be now x, so the first number, take away the second number, times the first number plus the second number. Okay, that is now fully factorized, that one there. And finally, we've got this one, two square numbers. Okay, so x plus 3 has been squared, so that's a square number. And 4 is the same as 2 squared. Okay, so we can rewrite this, x plus 3 all squared minus 2 squared. A difference of 2 squares. Okay, so same rules apply. The first number minus the second number. The first number plus the second number. Whoops, you don't need to put the brackets in. Okay, so all these times I'm using the same rules, the numbers are slightly different, so you've got to be careful. Now with this one, we have like terms. So these constants, they're called, numbers that are not variables, add together, add and subtract together. So 3 minus 2 is positive 1, and 3 plus 2 is positive 5. Okay, so we have a fully factorized form. Okay, I'm going to finish that video here, and I'm going to go on to some of the harder ones in a second.